time for more assembly programming on our own computer using our own assembly language. Now, quick disclaimer, I am recording this video again before the previous one came out, and I haven't had the chance to read any feedback on my question about which assembly style I should use. But I've thought about it a bit. I've looked up some actual instruction sets, and it really looks like our current architecture is so basic and so primitive that there isn't really much, what would you call it, elbow room for me to really try to mimic them. But still, I will try to slightly tweak my naming for assembly instructions so that they at least resemble actual instruction sets. And for that, I actually have found a RISC-V cheat sheet. Or here's the link if you're interested where I got it. Just a bunch of things. So, I'm not even sure how useful this is gonna be. And also, this is RISC-V, which is cool and all, open source and stuff. Oops. But it's not Intel, is it? It's not x86 or ARM. But, well, enough of that. I'll just come up with something as we go. Alright. Wait, actually, I don't think this is the level I want to start with, because it unlocks stuff as well as a manual entry. So I would rather prefer to get started elsewhere. Cool. The length of our week is 4 days. For some reason, our weekdays are named 0's days, 1's day, 2's day, and 3's day. That's convenient. I hear some Earthlings number their 2's day incorrectly. Yeah, doesn't really surprise me. Anyway, New Year is coming up, and we want you to calculate the weekday of everyone's birthday. We will give you the date, and you will have to do it in. And all you have to do is return the weekday within 8 ticks. Okay, so we're getting runtime limitations now. Okay. This level you're given a number as input, and you should return that number modulo 4 as a result. The challenge is that you only have 8 ticks to output the desired result. Note, you don't need to change your hardware, you just have to figure out the trick to do modulo 4 quickly. Use this hint if you get stuck. I see. So I'm guessing I get as the input the number of... Yeah, the number of days? Show me again. Tuesday, someday, it doesn't matter. We'll give you the date, so the date is just going to be a number of days. And I need to do modulo 4. Alright. Okay, I need to figure out how to do modulo 4 efficiently. Let's take a look at our ALU. We have our binary operations. Okay, well, I'm immediately starting to think, since 4 is a power of 2, that's probably gonna be helpful, isn't it? Because, yeah, if we have, I can even go, you know where I can show it off? Over here. The value modulo 4 is going to be exactly these 2 bits. That's all. Right? So we have an input, and we need to take the last 2 bits from it, because everything else is of course going to be divisible by 4. So that's it. Which means I need to... Well, I just end my input with all 0's 1 1. So I end with 3, bitwise end. And that sounds like a pretty efficient way to do things. So I'm guessing let's try. Right. Let's open up the IDE. Oi, new program. No new program. This is mod 4 dot overture machine language. I don't know. Maybe I should do something like awesome overture assembly. I don't know. Nah, I like OML overture machine language. Okay, and these I will probably rename. I will rename. So first of all, I intend to try to stick to some conventions. So for example, from what I gather, generally the registers in the processor are referred to by letters. So this would be register A, B, C, D, E, F. There's a million different variations on ABCD. There's like EAX, EBX, AX, BX, with X standing for extended, and a million other things, but I think my architecture is the most basic thing, where registers are 8 bits. So I'll just use letters, and I will use MOV for, and so actually, for a copy rather, I'm just gonna go ahead and rename all these. Can I? Yeah, I can rename them. So, done. Kind of. So yeah, to copy between registers, I'm gonna use MOV. This might be wrong. I realize this might be wrong, but I just want to get used to actual proper stuff. I know it's confusing, and I'm probably shooting myself in the foot. This is probably gonna be more difficult to reason about than 0, 1, 2, 3. You know, I'll have to translate A to 0 and then actually think about stuff, but I just don't want to get attached to my own architecture. So yeah, we have MOV, we have load byte. I decided to use for loading basically from input, so load byte into register A, into register B, into register C. I can add as many more as I want. And we have store byte, I believe. SB, same thing, but take the byte and put it into the output. So that's what we have, and now let's actually solve the problem. I'll probably have to add some more instructions. So okay, what do we want to do? We want, well, at some point we will want a AND, which, by the way, is this a arithmetic logical? Yeah, we have a logical operation that's just called AND. Wait, should I make it all uppercase? Okay, no, we're fine, we're fine. People don't use uppercase. It's not a skill. So, and yeah, this is an instruction which I want to add. Let's take a look here. Our compute, what's an AND? Cool, so let's add. Let's copy that here. This is going to be our bitwise AND, right? And before this AND, I need my input in register B, for example, and I want 4, constant 4, in or is it 4? No, I don't want 4. I wanted 3, right? Right? So we were going to end with this word, right? Yeah, just end with a 3 in register C, because A is not, well, the ALU doesn't read from register A, it reads from B and C. So before we do that, well, and after we have done the AND, we can output, so SB, right, save byte C. Wait, actually our output will be in D. Well, let's also add that. You know what, I can just use the SBC, turn it into what? Right, turn it into a D, like so. SBD, so we take from register D. Okay, that's gonna be our output. And now let's load, let's start with immediate 3. So what's immediate 3? Immediate 3 is, well, 3. Can I just do this? Oh, that's actually pretty cool. I think I can. So we're gonna have 3 in our register A, unfortunately. So I want to do move A, B, for example. And then we also want, or, you know, I feel more like putting it into C. And then we want load byte. We want to load from input. And we want to load into B. Is that all? Feels about right. I have 6 instructions. I'm not sure how many ticks that'll take, but let's see. So 3, yeah, we have 3 saved. Now, A to C. That's probably gonna take multiple ticks. Oh, no, it did. It's fine. Let's try this again. No, reset. Why are you broken? You shouldn't be broken. So yeah, we have 3, but now we move it all the way down to C. Cool. Now we load into B, 28. Now we do bitwise AND. Where does the output end up? Here. That doesn't look right. 28. 28 is divisible by 4. Why is my output? Oh, no, it's... Again, I'm messing up the registers. This is our register D. I would like to label them. And I don't think it's about A, B, C, D right now. It's more about the weirdness of... Oh no, we're starting all over again. Cool. Well, the program works. Success. Stats. Masking time. Architecture. Onwards. Let's crack some storage now. The security access door to the storage room is broken and it keeps locking your old janitor inside. The door keeps changing the passcode. We need a program that can recover the passcode at any time. Maybe just change the door? The easiest way to find the passcode would be to try all combinations until you find the right one. Although the broken mechanism does make a weird beep when your guess is too high, you might be able to use that to your advantage. What? Weird beep. How do I don't have a microphone. You win this level when you output the correct passcode. No output will fail the level. Additionally, the input will be 1 after a guess that was too high and 0 otherwise. So the passcode, I assume the passcode is a 1-byte number? An 8-bit number? Passcode. Let's make a weird beep. All combinations until you find the right one. But I thought... No, come again. The door keeps changing the passcode. When does it change the passcode? Does it change the passcode each tick? Huh. Well, I mean, my thinking right now... Huh. Well, this kind of doesn't sound possible. If the door keeps changing the passcode every tick to something random. I mean, I'll probably catch up to it at some point just at random, which, I mean, I can just implement a counter that will constantly add 1, add 1, add 1, add 1. Try outputting an increased value every time. For which, really, I just... I'm gonna do it now. Yeah, you're always on. Let's try this. Out of curiosity. Why? Oh, well, whatever. I win. I think that's a pretty efficient solution to the problem. Just delete the computer and use a single counter. I don't know. That's probably not in the spirit of the problem. I think they wanted me to come up with something more elaborate. Do I, or do I literally just settle for this solution? Because again, this is a little bit underspecified. How often does the thing change? Right, at which point do I just assume that we're done? Okay, well, so my thinking for perhaps a slightly more efficient algorithm is start from 0, keep ticking up. Example, label my label. Const by 3. Right, oh, that's actually pretty cool. Const by 3 is not bad. I already forgot how to jump, but yeah, this problem will require me to loop, so I should probably try to solve it using actual assembly. Just to get a feel for how looping works. It's gonna be our hashcat dot awesome. Let's see. So I want, here's my idea. +1, so do, let's, you know what I'm gonna do? I'm gonna write while true, counter +1, you know, something like this. Turn counter ++, but no, while, not while true. Actually, while true. If beep, then return counter, actually minus counter, else return ++ counter. Right, well, and counter equals 0. So this seems like one simple solution to this. I could also try doing binary search, but this, I feel like this depends a lot on how quickly the thing will move. Or does binary search always, would binary search always be better for this? I think it might be. See, my intuition just tells me that if it changes often, I do not want to do large jumps, because large jumps of my binary search will just get me farther from it. Future self here. So I've spent probably 40 minutes or something trying to write this program and trying to understand why it doesn't do what I expected it to do. And basically, I was again misunderstanding the problem statement, although this time I think it's even more confusing than the bus. So what the guy says is, what does he say it? I think it was at the very beginning. Yeah, the door keeps changing the passcode. And I did ask this question a bunch of times, and it wasn't clear to me when the passcode change happened. Now, there's multiple possibilities for this, right? It might just randomly happen or not happen on each tick. It might actually happen on each tick. Or it might happen on every 10th tick. Or it might happen on every 100th tick. But it looks like what's actually happening here is the door keeps changing the passcode every time a test is rerun. So every time I press the run hotkey or the run button, the passcode resets. And this means that my original idea, which I don't even remember at this point, to be honest, but let's just real quick try to re-implement it. It was something like while true, right? I was saying if beep, then we're too large decrease, something like this, right? And then else counter increase, something along these lines. Well, there's a bunch more, but of course, if we're starting from 0, we're incrementing by 1, and the passcode never changes, then all of the logic regarding the subtraction is completely irrelevant. And this, I got stuck on this for a very long time. I was setting this breakpoint, and it would just never go into subtraction. It just never would subtract. And I thought that something was wrong with my program. While in fact, really, if you take a look at this register, it just keeps very slowly, I might add, growing up. Right? It keeps growing up, so it works. And we actually simply complete the test when we find the thing by going up. So really, while adding +1 at every step, we cannot miss it, and therefore we never need to subtract. We can never overshoot. But my original understanding of it was that the thing might change mid-test, and that I would need to try to kind of chase it, right? To go up, down, if it changes, and hopefully catch up to it that way. Now, again, I realize this, depending on how often it actually updates, that might have been inefficient, but still, that was my understanding of the problem, and that was the idea. And I don't think keeps changing the passcode is a specific enough problem statement, basically. So anyways, yeah, I have a bunch more instructions now. They're all just copies of the same thing. What I thought I might do instead, because I am annoyed by this problem, by the fact that I couldn't nicely solve it. This is a bad solution, very bad in fact. It's very inefficient, very slow. It's much slower than just having a counter. And I have a hope that I might be able to implement something faster than just a counter ticking up. Is it OML? Yeah, OML. Cool. And I have two ideas, which one of them I think I've already expressed. This immediately comes to mind. It's binary search, right? That, I believe that'll be the most efficient algorithm for this ever. I think there's no more efficient algorithm even theoretically possible to solve this issue. Well, on average, in general. But that is a bit far off because, like I think I mentioned, I cannot multiply by 2 and I cannot divide by 2. I don't have that functionality in my ALU. So I will not start with that, although I am considering going into my architecture and actually adding bit shifts, shift left, shift right, to my ALU, because I do have, actually, if you take a look here, our instructions, I do have exactly 2 unused. Is it 2 or is it 3? No, I have exactly 2, as you can see, unused compute instructions, and I can just use them inside of here and call them shift left and shift right. Just a single shift. I think it's not worth implementing a shift by n, because I won't need it here, and I think it's going to be much more difficult to implement. But yeah, I think that I can and probably will do. But we'll see depending on how the other option I think would be viable goes. So let's start a new program. Let's call it John.oml, because hashcat and John. And here's the idea. I do large leaps up. So I start at 0, right? Let's say I start guessing at 0. Then I guess 0 plus n. Then I guess 2n, right? Then I guess 3n. Then I guess 4n, where n is some number other than 1. And at some point, I overshoot. But once I've overshot, well, I will know it will beep, right? I have to check for beeps. And once I've overshot, I can start going down with 4n minus 1, 4n minus 2, and so forth, until I actually find it. And this means really that I will need to do a number of jumps up, and then at most n jumps down, right? Which is fairly efficient, I hope. Now, of course, actual jumps are going to be multiple instructions, but that's a different story. So let's try to implement that. Now, let's say, okay, remind me what a constant is. Instructions? No. Terminology? No. Assembly. Yeah, so let's say our const jump is whatever, 1. For now, this is what we currently have, pretty much. Yeah, actually, that's an interesting thing. We currently have this jumping behavior implemented here, except instead of jumping by n, I'm jumping up by 1. But whatever, I will re-implement it anyways. So how do I program this? Should I perhaps, I have another idea. BRB. Something along these lines. I think it's going to be easier to work with assembly. Sorry, my wrist needs to be a different color. I think it's going to be easier to work with assembly in this kind of visual format. At least for me, that feels like it should be an improvement. So what do I want to do? I want to start adding, what did I call it? Sorry. I want to start adding, let's not call it jump, let's call it n. I want to start adding n on every step. So this means that first I need to load my n, which means I load n. This is going to be like immediate n. And take a look at what I'm going to do. I'm going to literally move things around here. So once I've done immediate n, I have my n here. Now that my n is here, I can do move a to... So we're going to be adding n to our number. So let's move it to c. Yeah, and actually that's a good idea. We'll see later. So now our n is in c. No, yeah, see, that's why I'm putting it next instead of inside the buffer. So yeah, these are buffers, by the way. There's just symbolic reminders of where arithmetic happens, where stuff loads, what happens elsewhere. So yeah, now we have our n in C. And so first what we want to do, before we do any addition, we want to make our first guess. Our guesses are going to be ending up in D, right? So let's try, let's not worry about the loop for now. And let's try to say save byte D, right? So we output our D. This is currently 0, by the way, right? As well as B is also 0. So our current guess is in D. Now, it just so happens that it's 0 right now, but in the future, I will want to move my number, my guess. So let's say this is guess. Before starting the next iteration, I will want to move my guess to B, right? Like so. So we're gonna say move dB, right? And then we do addition. And then we guess again as BD. And then what do? We move again. We add again. And then we output again. So what's our loop here? It looks like the loop is something like this. Except I need another guess at the end. Or it could be guess 0 and then loop like so. So let's try this instead. Right. This is gonna be, we're gonna guess 0 first. And then we're gonna start looping. But of course, in order to loop, what I need is I need labels. So let's say I put a label, I call it label ink up here. This is gonna be the start of my loop. And then let's say for now I'm gonna unconditionally jump. I have an unconditional jump called J. But in order to jump to ink, I actually need to load my ink into here. And then an unconditional jump will put ink into here. And we're good, right? So, but this is currently not, this is just gonna keep adding and guessing until until the cows come home, really. Especially if we don't, it doesn't matter if overflow doesn't bring us to the actual answer. So now we want to add the logic for actually stopping addition, stopping growth, preventing increasage. And instead we want to start subtracting. So first of all, I think there would need to be, so I don't need to switch between these two loops, right? First, I always do plus n, plus n, plus n, plus n. Then once I'm done with plus n, I will never need to return. So it's probably safe to say that after this, I do my initialization. So this was kind of the initialization for the increase loop. And let's now do the init for decrease loop. So I want immediate 1, which is actually just 1. And once we've done immediate, we will have 1 in here. Our guess is our guess. Okay, so I have a problem here because once I have looped, after the loop, our guess is only here. So I should probably make my loop slightly different. Yeah, see, this is a pretty standard thing in imperative programming, but just assembly breaks my brain. So yeah, at the end of a loop iteration, we have a guess here, and this is gonna be previous guess, right? So if I now do immediate 1 and I put it into C, which I do need to do anyways. Move immediate guess. So move A to C, right? I no longer have N. I'll have my 1 in here. I think I also want to move my guess at the start of initialization phase for subtraction. But again, this could use an improvement. I think I could make this loop slightly neater, because I have pre in it, post in it phases, which does not look good. But for now, let's proceed. I think let's proceed. And actually, I pretty much just repeat this loop again. So label increase, label decrease. This is going to be jump to decrease. I move my guess to my B. I do subtract, right? Sub. So this is going to be my next guess now. It's going to be guess -1, which, by the way, this works out nicely. The reason I put N into C at the very start was to have this 1 later at the same buffer, or at the same, sorry, what's it called? Register. Because to subtract 1, I cannot subtract guess from 1. I do need 1 to be in C, so that's nice. Okay, so again, we get a new guess. We guess it, and we jump back. And this actually we repeat forever, so this is literally correct. This is literally correct. All of this, I think, is correct. So all I need is, I now need a piece of logic to stop looping here. So, all right. In order to stop looping here, I will need to check my input, right? Oh, actually, that's a good... Maybe I should add input and output in here. I'll do that. Well, there's not many arrows I want to draw here, but yeah, so we want to load our beep from in. It's gonna be our... And because jump checks D, jump if happens based on D, we will want to load into D. So load byte into D at the end of the loop, or in the end of the iteration, right? And now that we've loaded, so we will have beep here. Oh no, I lost my next guess. See, this is a problem. So let's not... I do want to do... Yeah, this is an issue regardless, because... Wait a minute. Give me a second. Okay, how about this? Let's not guess based on D. Let's try guessing based on D, or guess goodness. Let's try guessing based on B. So let's say save byte B here. And let's just eagerly move our answer into B every time. How about that? So I add first, then I eagerly move to B. Then I output B. And then I load into D. Is this gonna work? So let's see. Immediate N. Let's restart this. Let's see what happens. So immediate N, call, AC, call, save byte B, guess 0, call. Now we get in, we save, or we add, we get our N, get our guess. And now we move it back into B. We move it back into B. And now we guess B. That's good. We guessed a new guess. And now we load our input into D. And now we can actually check. So jump. When am I jumping? I keep increasing if I did not beep. So if 0, right? I need to jump if 0. Is that correct? Let's take a look here. It does make a weird beep when your guess is too high. So if I'm too high, I have beeped. That is 1. So I need to keep looping until I start beeping. Yeah. Okay, cool. Now, so let's say I've looped a bunch of times. I will always, at the end of this, I will always have this kind of setup. I'll have and here, my current guess here, and my beep saved into D. So what do I need to do now? MovDB. I don't need this anymore, which is great. And yeah, I load immediate 1. I move it into C, so my n dies. And then I start decreasing. Which I guess I can keep this structure. Move db. No, I cannot. I cannot keep this structure anymore because I currently have my beep. But I have already guessed the guess, so again I can sub. And I get next guess. Next guess. Then I sub. Then I move. I get my next guess. And then I guess. And this just becomes my guess. This is no longer next guess, this is just guess. Like so. And this I keep doing forever. So I think we figured it out. Hopefully this will work. So let's try. Const n. So immediate n just n. And I can actually copy everything else. Okay, I'll do that and I'll be right back. Right, so this I think is gonna be my program. Let's just test it with n equals 1. Let's see how it runs. Does it do anything useful? Oh. This looks broken. This looks broken. So let's take a look. N. I loaded. I should have my 1 in here. Save byte B. Yes, I tested. I add. I move again. Or rather, I move there. I save byte. I load byte. Oh, I cannot. I don't have JZ. Right, I forgot. It's okay, it's fine. We're good, we're good. I need to add an instruction for jump f0. So condition equals 0. Let's say this jump 0. Now we have a jump 0. Let's test this again. Okay, it looks like we're going up by 1. Yeah, okay, this looks cool. All right, now for choosing an n. I actually have an idea, which I think is gonna be a pretty good rough estimation. But let's see. Let's open this up. So this is our program. Let's save it. So on average, I will need to jump. So really, the average guess, pretty clearly, is gonna be 255 plus 0 divided by 2, right? But let's just say it's 128. The average value of the code, right? The average value that we need to guess. If I'm going up by increments of n, then on average, I will need 128 divided by n steps to go up. Right? And then once I'm done, I know that I am in range. Well, basically, I know that the previous addition was too low, and this one is too high, probably. So I am in an interval of 32, right? So I'm gonna have my previous guess here, and I'm gonna have my current guess. And I'm going down, like so, subtracting ones. And the size of this is my n, right? But on average, again, I'm gonna need to go just to the middle of this range. So on average, I'm gonna need to make n divided by 2 steps, right? Going down. So this is average number of steps. This is, I understand this is a rough estimation, but I think that'll be helpful. Average steps. Right? So in total, I need 128 divided by n plus n divided by 2 steps on average. Right? This is the total number of my steps. So now I need to minimize this, basically. Okay. Well, I know what I'm gonna do. Dark mode warning. Dark mode warning. We're gonna have a huge white screen in 3, 2, 1. Yeah, this burns my retinas. Okay, so here we go. We're just gonna use a graphing calculator. So we had 128 divided by x plus x divided by 2, right? That was our function. We need its minimum in positive x, of course. And there we are, extremum. Not sure how you pronounce it in English. 16. Huh. That makes sense. It doesn't really, but it's a nice number. So let's set our n to 16 and let's try it now. We have 16. We add 16. We guess 16. 32. Still 0, 48. Still 0, 64. I'm gonna put a breakpoint on here. Let's just... 80. 96. 112. 128. 144. 160. Wow, that's a big number. Wow. 200 and 240. Wait a minute. Why am I always 0? Something is wrong. Something is wrong. I'm just gonna keep looping forever. Well, wait. Was I? What happened there? It kind of looked like it was going down. Let's check again. Yeah, see? It was going down right there. Also, we have a short circuit. Wow, I have a short circuit in my PC. What? How do I have a short circuit? I don't even... Okay, I think the issue might be... We might be overflowing, I think. I think we're probably overflowing. If the number is very large, if the number is between 256 and 240, we might be getting back into 0, and that is an issue. How do I solve this? That's actually that's an interesting question. How do I solve this? Well, let's just try 15 for now. Let's see if 15 works at least, because that shouldn't overflow as easily, although it will still overflow. No, I think we found it. Yeah, it goes down, so let's just do this quickly. Or now let's add more breakpoints. So, or even, you know what? I'm gonna add a breakpoint over here so that we can see 15. No, this is better. 15, 30, 45, 60. We go up, 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 up to 55. 1. Now we're too large. So we should jump. Or rather, we don't jump. Great, so 255 is fine. Cool, yeah, and it actually, so it looks like 255 divides by 15, right? It's divisible by 15. Is it? I can't be bothered. 255 divided by 15. 17, yeah. So that's nice. This means we will not overflow ever. So if 15 is a nice constant, I'm just gonna use it even if it's not that efficient. So let's see now. Are we fast? Yeah, I'd say this is decently fast. I'd say this is decently quick. 241. Are the guesses always different? No, it seems like they're always the same. Could I just output to just hard code an output and just solve it in one tick? I think I could. But yeah, I think this is a fairly nice solution. Pretty short. Decently efficient. And now the question is, do I go and implement binary search? I mean, that would be interesting. But I feel like it's not gonna be that much more efficient, to be honest. Just because we are very limited in our operations, and even though it's technically gonna take 8 iterations of a loop, or 9 or whatever, off by 1, the problem is there's gonna be a lot of moving things around and saving into, we will have to keep track of high and low, and we're gonna have to add them together. We're gonna have to divide that by 2, and then we're gonna have to decide whether we are adding or subtracting this from high or from low. Then we're gonna again have to keep track of high and low after we've done that. So every loop is probably gonna have a whole lot of instructions, or every loop iteration. And I'm not sure it's worth it. I think we'll get a more powerful computer later, from what I gathered reading the comments, which should probably have multiplication and division, and hopefully will support more features for my operations. So for example, I can do addition from A and E into C, that would be very helpful. That would save a lot of moving things around. So yeah, I'll probably settle for this. Maybe if I really feel like it, I might do bonus footage. But for now, I'm gonna say that's it. To stick around, if bonus footage is there, it will be appended right now.